Okay, this lesson is about box and whisker plots. So a box and whisker plot is a way of showing several important features about a data set on a graph using what's called a box and whiskers, which are really just points. Okay, so what a box and whisker plot does is it divides a data set into a lower quartile and an upper quartile. A lower quartile is just the median of the lower half of the data, which is everything that's below the median of the entire data set. So what we're going to do, we're going to find the median of the entire data set and then break it up into halves, essentially. The first half is going to be everything below the median, and then we're going to find the median of that again, and that's going to be our lower quartile. Then we're going to take everything that's above the median and find the median of that again. That's going to be the upper quartile. So the upper quartile is the median of the upper half of the data, which means everything above the median of the entire data set. Okay, so to construct a box and whisker plot, the whiskers show the minimum, the smallest, and the maximum, the largest data values. The box shows the lower quartile, the median, and the upper quartile. The lower quartile and the upper quartile, again, are medians as well, but they're medians when you separate the data from the lower half and the upper half. Okay, and the order of our box and whisker plot goes like this. The minimum first, then the lower quartile, then the median, then the upper quartile, then the maximum. And what you also have to know, the interquartile range, the IQR, is the upper quartile minus the lower quartile. Okay, let's get into example. So here are yesterday's high temperatures in Fahrenheit. Okay, then we have for 16 US cities. Notice the temperatures are ordered from least to greatest, so great, we don't need to order them when we're finding the median. Make a box and whisker plot for the data. So before we make the plot, we want to make a list of the values we need to get the plot. So we need minimum, lower quartile, just call it lower Q, the median, the upper quartile, and the maximum. Okay, let's start with minimum and maximum. Those are really easy to get. So the minimum, the smallest number in the data set, is 49. The max, the largest number, is 83. Okay. Now, let's get the median for the overall data set. So I like to do it crossing off numbers. You may do it a different way, that's fine. Okay, so since we have an even number of cities, we have two values in the middle, 68 and 69. So to get the median, we're going to go 68 plus 69 divided by 2, which is 68.5. Okay? Now, to get the lower quartile and upper quartile. So we're going to separate everything into let's put 68.5. The 68.5 is going to be right here. I'm just going to draw that in. So to get the lower quartile, we're going to take everything that's below the median So all these, and get the median of that. So let's rewrite it. 49, 55, 61, 62, 64, 67, and 68. Okay, let's get the median of those. Okay, the median of those is 62. So our lower quartile value is 62. All right, now to get the upper quartile, we're going to take everything that's above the overall median, above 68.5. So it's going to be these values. Let's write them out again. Okay, 69, 70, 71, 72, 72, 81, 81, and 83. Okay, so to get the median of those, okay, we have 2 in the middle, so they're the same. 72 plus 72 over 2 is still going to be 72. So the upper quartile is 72. Okay, let's plot these values. The minimum, actually I'm going to have to extend this by 1. They didn't give us enough room on here, but that's fine. The minimum is 49. Okay, the lower quartile 62, so that's going to be over there. The median 68.5, 66, 67, 68, be about there. And the upper quartile 72 over there. And the max is 83, which is over there. Okay, so to make this, we're going to put a box around these. Okay, this is our box. Oops. And connect everything, okay? That's your box and whisker plot. Okay, let's try another one. So distances in miles to the nearest airport for 17 families. And again, we're making a box and whisker plot. So let's write out what we need. We need min, lower quartile, median, upper quartile, and we need the max. All right, so easiest ones to start with, min and max. 11 for the min. They're in order, so we don't have to do that. Maximum is 43. Okay, let's get the median. Okay, we only have one number in the middle because we have an odd number of families, and that number in the middle is 29. So our median is 29. All right, for the lower quartile, we're going to take everything that's below our overall median, 29, so these values over here, and we're going to get the median of those. So we have 11, 12, 13, 2 17s, 23, 26, 27. So the median of those, you have 2 in the middle, they're both 17, so the median of those is still going to be 17. So the lower quartile value is 17. For the upper quartile, we're going to take everything right of the overall median. The overall median was 29, so we're going to use all the values to the right of it, which are those. So we have 31, 32, 2 35s, 40, 41, 42, and 43. Let's get the median of those. We have 2 in the middle, So we're going to go 35 plus 40 divided by 2, which is going to be 37.5. All right, so let's plot. The minimum is 11. The lower quartile is 17. And 17 be like there. Oops. 29 for the overall median. The upper quartile, 37.5. And the maximum is 41, 42, 43. Okay. So again, these guys get a box around them. That's your box in the box and whisker plot. And then the outside are your whiskers. That's it. Okay, different kind of question is, instead of constructing a box and whisker plot, you're given 2 box and whisker plots and you have to compare them. Okay, so we have 1 box and whisker plot for athlete A and another one for athlete B. So the training for a cycling race, each athlete recorded the distance of their previous 95 rides. So they rode 95 training rides and they wrote down the distance, how many miles they ran in each. And this box and whisker plot summarizes the data for each. So for athlete A, let's write out what he has: the minimum, the lower quartile, the median, the upper quartile, and the maximum. All right, so his minimum is 14. His lower quartile is 17. His median is 22. His upper quartile is 31. And his maximum is 37. Okay. And then for athlete B, min, lower quartile, median, upper quartile, and maximum. Okay, so for athlete B, the minimum is 19. The lower is 21. Median is 25. The upper quartile is 27. And the maximum is 29. Okay, now we have enough information to solve, almost. But the first question asks about interquartile range. So we talked about interquartile range briefly in the front. We said interquartile range is the upper quartile minus the lower quartile. So let's add that in. So athlete A, IQR, is upper minus lower. So it's 31 minus 17, so his IQR is 14. For athlete B, his IQR, again, upper minus lower, 27 minus 21, which is 6. Okay, which athlete had distances with a larger interquartile range, IQR? Athlete A has the larger interquartile range. Which one went on the shortest training ride? Well, that's talking about the smallest minimum value. Athlete A has a minimum of 14, athlete B has a minimum of 19, so athlete A has the shortest ride. Which athlete had the smaller range of distances? Well, we know range is maximum range is max minus min. So let's add this in. So his range for A, the max is 37, the min is 14, so his range is 23. Athlete B, the max is 29, the minimum is 19, so the range is 10, which had the smaller range of distances, so that's athlete B. And then which had the greater median distance. Athlete A's median is 22, athlete B's median is 25, so the greater median is athlete